Here in this video, we are going to talk about graphing a square root function. So it's kind of self-explanatory, but basically we're going to discuss how to graph a square root function by using either a table of values or a t-chart, or by what I call the transformation rules, and I have one example of each. So we're first going to talk about the parent function of the square root. So you'll see that the parent function looks like this. The graph of a square root kind of comes around like this. You want to think of it as half of a parabola turned on its side, because that's actually what it is. So when I'm graphing the square root function, you get to pick, if you're doing a table of values, you get to pick the values that you want for your x values. So typically when you're doing a t-chart, you usually want to choose negative numbers, you want to choose 0 and positive numbers. But for square root, this one's a little different because you can't take the square root of a negative number, and so I'm only going to choose 0 and positive numbers. And you'll notice that I strategically picked some different numbers here, that it's not just like 1, 2, 3, 4. So you might ask, well, how come I picked 0, 1, 4, and 9? Well, I'm going to pick numbers that I know the square root of really easy, so it's easy for me to graph. So I know that the square root of 0 is equal to 0. And then I picked 1 because I know that the square root of 1 is 1. And then I happen to pick 4 because that's my next perfect square. So if I take the square root of 4, that gives me 2. And then I jumped all the way up to 9 because that's the next perfect square on the list. If I take the square root of 9, that gives me 3. So I plotted my points, and it gives us the graph of the square root, which looks like this. So how the transformation rules work is if you know that these are your points of a square root function, so 0, 0, 1, 1, 4, 2, and 9, 3, what we can do is we can use our transformation rules by moving our graphs up and down and right and left based off of these points. So here's kind of how this works. So if I'm looking at a generic square root function, okay, it's going to look something like this. Actually, technically, it's going to have an a in front here, but we'll talk about that in a minute. So if I have this minus h, the number that tails with the x, or inside my square root, is going to move my graph right or left, and it's opposite of what you would think. So if you have something that's minus a number, it's actually going to move it to the right. But if it's plus a number, it's going to move it to the left. Now the number on the outside, this blue guy right here, this plus k, is how it looks. And k moves our values up or down. So if I have plus a number, then my value is going to go up. And if I have minus a number, then it's going to go down. So what we want to do is, I have my example, first one for you right here, is looking at this example. So I'm on the first example right here, number 1. It says y equals the square root of x minus 2 plus 3. This automatically tells me, so this minus 2 tells me that my graph moved 2 to the right. And this plus 3 tells me right here that my graph moves 3 up. So when I go to plot my first point of my square root function, I'm going to start, normally I would start at 0, 0, but now I'm going to go 2 to the right and up 3. So this is actually where I'm starting. So I just want to show you, if I sketch in for you, here's my square root function. 1, 2, and then I'm at 4, 2, and then 9, 5, 6, 7, 8, 9, 1, 2, 3. So my regular square root function looks like this. You're going to take each of these points and you're going to move them right to up 3. So then I'm going to take this point right here, I'll make it orange, and I'm going to move it right to 1, 2, up 1, 2, 3. Notice that it's in the same location, up 1 over 1 from my blue point. So let's make this point green. So this green point, I'm going to move it right to up 3. It's going to be right here. Notice it's in my same location. It's 3 over and 1 up from my orange point. And then my last point right here, I'm going to make this pink. I'm going to move it right to up 3. And here's my point right here. Notice it's in the same location. It's over 5 up 1. for my green point. So my actual square root graph this time, oops, sorry, looks like that. Let me try it one more time so I can get it through my points. Close enough. Okay, so you can see that I literally just took my graph. If I took this graph and I just moved it, okay, I just slid it. So that's how a transformation works. I'm just taking my graph and I'm literally sliding it around the XY plane. So that's the easiest way that I like to graph these square root ones. Now it gets a teeny bit trickier when you have this value a up in front, because what it does is it kind of changes like the fatness of your square root. So it can make a square root function. Typically if your square root function looks like this, it can make it either really fat or it can make it really skinny. Okay, so when you have a number out in front like that, for me the easiest thing to do is to use a t-chart. So down in my next example here, I'll erase those, sorry about that. I'm going to go ahead, I already have my graph drawn, and I'm going to go ahead and I'm going to plug in my numbers. So I have 3 times the square root of 0 minus 1. So the square root of 0 is 0, 0 times 3 is 0, and 0 minus 1 is negative 1. Then I plug this in. 3 times the square root of 1 minus 1 is equal to, well, the square root of 1 is 1, 1 times 3 is 3, and 3 minus 1 is 2. Okay, so then I have 3 times the square root of 4. Now you might say, well, how come you picked a 0, 1, 4, and 9 again? Those are the numbers that are my perfect squares that are easy for me to take the square root of. So those are going to be the numbers I'm going to choose for plugging in values because it's the easiest thing I can do and I don't get nasty decimals when I'm graphing. Okay, so square root of 4 is 2. 3 times 2 is 6. 6 minus 1 is 5. And then last but not least, 3 times the square root of 9 minus 1. So the square root of 9 is 3. 3 times 3 is 9. And 9 minus 1 is 8. So now I'm going to plot these points. I'm at 0, negative 1 here. I'm at the point 1, 2 here. I'm at the point 4, 5. So 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4. 1, 2, 3, 4, 5 here. And 9, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. 8. So this graph looks like this. So you'll see when this number out here is bigger than 1, it really stretches out your square root graph and makes it really fat. As opposed to if it was a number that was between 0 and 1, it would make it like really skinny, kind of close to the axis like that, just so that you have an idea of how that works. So you can either choose to make a t-chart, and this t-chart will work every single time, or you can choose to kind of use this this transformation rules to move your parent function around. Either choice works. It just depends on what you feel comfortable with. Good luck. Let me know if you have any questions.